Okay, that's fine. Now, first of all, let me make a general premise. First of all, I just would like to make a check. Can you understand well my English, or it's a problem? Nobody's problem with my English? Okay, this is, it means that it's improving probably, I hope so. Okay, and general premise on the PC and etc. As you see, probably you notice that I am a Linux user, and I'm not fanatic of the Linux, but I turned to Linux 5 years ago, and basically the main reason why I decided to turn to Linux was that I couldn't stand any more viruses attacks, because I have my PC in which I work that is always connected to a static, with a static connection to the web, which means that a static connection means that it has a fixed address, so it's more vulnerable to external attacks. And I was subjected to several attacks, and any time I had to, to start from the beginning, and so I decided to turn to Linux. This was the main reason. And indeed, after I turned to Linux, I didn't have any attack anymore. And also I appreciated the fact that it's not overloading the PC. So I noticed maybe that I was just lucky, but I noticed that also the crashes, the number of crashes and failures of hard disk and other hardware components decreased. Because, and also I noticed that the battery lasts longer for the personal computer because it's loading the machine less than Windows. And also I appreciated very much the fact that it's open source, and I could find a lot of programs, I would say like 10 times more for free on the web, completely free, for any kind of application that I wanted to make. But at the same time, I also experienced some problems, and the main problem of Linux with respect to Windows is the compatibility with everything that you plug in with the computer. And basically now the situation is very good, but still I have some problems with the compatibility with the projectors, and in this case it went well, but indeed with Windows is better. And also I have some problems when I use, I still think that Microsoft Word and Excel, Microsoft Office is the best Office application today available. So I tried with many emulators like LibreOffice or the last one that just was released, I don't remember, King Office or something like that. And there is unfortunately still the performances are not comparable. There is no comparison, they are not comparable. The performances of Office are much better. And also apart from the performances, there is the problem of compatibility. Compatibility also with PowerPoint. When I go to conferences and I use PowerPoint presentations, still the compatibility is not really good. So these are the only two problems which I solved by installing a virtual machine on the Linux computer, and also by installing the emulator Wine, which works quite well. I'm saying this because I strongly recommend to you to convert to Linux unless you have some specific needs. And the reason why I am giving to you this suggestion is not just because I am a fanatic. I think that ideally a good engineer should have a full overview of what is possible and what is available, and then take from every single component the best. This is the ideal solution. So for Windows, for instance, I think that Microsoft Office is still the best, so I'm still using it. For Linux, I think that the vulnerability, or let's say the safety of the system is the best, so I'm using Linux for this reason of safety. And so this is what I suggest to you to have. You should learn everything. I know that it's tough, but it's not so tough as you feel. It's easier than expected to move from Windows to another operating system. Easier than expected. You just take the CD, you plug in the CD in the PC, and it goes up Linux without any problem. And you can, for sending email and browsing the web, there is no difference. So it's easier than expected, and as I said. So the ideal thing that I recommend to you is to learn it, and to try to figure out, according to your needs, what are the best solutions and pick up the best ones from each system. In general, if I had to suggest a student one single operating system, I have no doubt in suggesting Linux for the reasons of program availability on the web, which is really great. Even for engineering, it's really great. And the reason of safety and the reason of the fact that the performances of the computer are much better. Definitely. Also, you may know that Windows has a problem, that it has a file that grows continuously. And it makes the performances of the system decreasing over time in a way that after, on average, 2 years, the PC becomes too slow to be used, and you need to reinstall the operating system. There is no other way to solve this problem. And of course, I said 2 years, but it depends on the time that you are using the PC. Keep in mind that every operating system has this decreasing performances effect. Everyone, including Linux. But Windows is terrible. The decrease is really very, very rapid, and you can really feel it. And this is the reason why in the past, for instance, I used to change the PC after 2 years, because after 2 years, if you need to reinstall the operating system, then you say, okay, let me take another PC, because you know, after 2 years, a PC, especially in the past, was getting older, and so this is really a significant problem, which with Linux you avoid, basically. There is a decrease, but you can't really feel it. So, this is my preliminary suggestion. That being said, now I open R in my Linux PC, and basically there are a few differences only with your version for your, or the version with Windows, let's say, which I'm going to explain. Just before I start, I make a check. Every one of you has installed R already on the PC, okay? And I want to make sure nobody of you used it before, or somebody of you used it. Nobody. Okay, that's perfect. It's really perfect because so we are all at the same level. So basically, who is using Windows among you? Everybody? Or there is some Linux user here? No. Okay, perfect. Now, in Windows you can start R by simply clicking on the icon. So I guess you already started it. Don't look at the screen for now. I guess you already started it. And did you start it already, everybody? Okay. So I think you got a window where you can see a menu in the upper part, and you can see a command line within a blank screen or a black screen. It doesn't matter the color. You see basically a command line. What is a command line? Is a kind of, let me see, let me start it. It's something like, let me increase it. It's something like the one that you can see there. So it's a major sign with a black cursor, which means that the PC is expecting your input. Correct? Can you see it? Okay, that's fine. So let's forget now the menu, because I don't have it, and it's not really necessary. Because in R, everything can be made by using the command line and the keyboard. The menus are shortcuts, meaning that with the menus, you can do in a quicker way some things that I will tell you how to make with the command line as well. So you don't really need the menus. And in the original version of R that was conceived for Windows, you can't see the menus. The menus that you see above are my menus of the console program, which is not related to R. So basically, in Linux, I don't have any menu. And this is the way it was born. When they built the version for Windows, they decided to put the menus because, you know, Windows users feel more comfortable with the menus. But let's forget about them, okay? And also, I should say that I'm not really the best person to teach to you how to use the menus. So you may try by using some guidebooks to learn what every single item in each menu does, in each window menu does, but as I said, I am sure that this is not strictly necessary. So, basically what you see is a command line. A command line, as the name says, is a line waiting for a command. And basically the program is waiting for your input. And of course, this means that the program is not user-friendly. There is not a user interface, which means that if you don't know the commands, you can't use the program. And this is a philosophy that, of course, is not the philosophy of Windows. Windows tries to be user-friendly, and it's very difficult that you see a command line in Windows. Usually Windows programs have no command lines, but just menus. Of course, you may say that having a command line is not comfortable, makes you not comfortable. On the other hand, you should note that when you have a user interface, the user interface is very rigid. You can do very easily what the user interface allows you to do, but you can't do anything more. Instead, with a command line, it's more difficult, but in principle, you can do everything that you want. And this is another basic difference between Linux and Windows. Windows allows you, imposes you what you can do with the computer. With Linux, if you know the PC, if you know the architecture of the machine, you can do everything you want. And this is another, from a philosophical point of view, I would say that Linux is the symbol of freedom for you. You are deciding what to do with the PC. It's not the PC that decides, or the operating system that decides what you can do. From a practical point of view, if you like playing with the PC, of course Linux is much better. Because you can do, as I said, everything. Just go on the web and Google for what you want to do and put Linux in the Google keywords, and then you get information from the internet. Okay, so now the problem that we have is that we have to learn these commands, because otherwise we can't do anything. And of course I provide an introduction to you, and if I can't tell you everything, because basically R, like with other programs with the same philosophy, have a lot of possibilities. And also one thing that you should know is that now we are working with a basic installation, a basic version. There are many plugins on the web that you can put into the program. So if you want to find plugins for engineering, there are a lot of them. If you're interested in economics, you can put plugin for economics, and etc. So basically, I will give to you an introduction, and we will develop together the relatively simple exercises that I will propose to you. But if you want then to become an expert on the program, of course you have to take some guidebooks for free on the web and study them. And once that you know the basics, it's very easy to learn the other issues that you want to do. Before I move forward, I just want to give you an overview of what you can do with a program like this. And also with MATLAB, with the difference that MATLAB, you know, it's a bit, it's a different philosophy and it's commercial. But also with MATLAB you can. And I want to show you a couple of pictures that I made with R. Because the interesting thing of these programs is that you can draw very nice pictures. And let me, I have to find it, just 1 second. Here they are. Let me see if it opens it. Okay, this is one animated picture that I did with R. This is, I'm sorry that really, it's not really the best. This is a picture of river flows of the Po River. And I decided to plot it in this way because I wanted to make a 3D picture with the discharge in the vertical axis, and on the horizontal plane you have years and days. So you have each year plotted just one close to the other, and then I smoothed the picture. So you can see in summer, you have this valley, which means that you have the minimum flows. And you see the floods in blue, and you see that the floods occurred, if you look here, many floods between 1980 and 2000, and if you look in the days, the floods occur between days 250 and 365 in the fall season. But you also see an high flow period in the spring. So this picture, once that you take some time to look at it, it's really clearly tells you what is water resources availability in each year and each period within the year. And it's interesting to know that the summer drought, which is a reason of concern for water resources management, it is more severe in a recent year, but also in a period between 1940 and 1950, the drought was very severe. So it seems, by looking at this picture, that you can see the effect of climate change that also occurred in the past. But what I just would like you to see is the power of a program like this. And think that when you present your work, if you can present your work by using these tools, of course, your convincing power is much more enhanced. And in water resources management, we need this. We need to be very convincing, because I told you that our main problem is to convince people that our decision is correct. So it's extremely important that you can prove to people that you can use very advanced tools and to show very nice pictures. Because a nice picture is convincing and also proves that you really made an effort in what you did. And for the same reason, one thing that I'm anticipating to you, in water resources management, it's very important to be able to use, how to say, a Photoshop, a program like Photoshop, a program for manipulating images. Because it's very important when you present your results, if you can really present very good pictures by putting also some real pictures into your graphs to show the situation in a, let's say, artistic way. It's really important. And if you want to have a refined look to this picture, there is a paper published on the web. I tell you how to find it because it's open access. I didn't link it to my website because it's open access. And you just have to Google. I'm now Googling in the upper window. You can Google Montanari S, which means Hydrology of System Sciences, and Po River, and I think you go straight to it. Let's see. Yeah, it's here. You know, the first item, Hydrology of the Po River. And you should refer to, this is a paper page, and let me see. One should refer to final revised paper you see here, because this is a scientific journal that is a bit complicated. It publishes also the first draft and then the final published paper, and one should refer to the final published paper. And here there is this is the final published paper, there is the supplementary material. I don't know where it is, let me see. Supplement, okay. Supplement here. If you click on supplement, you get these pictures. This is just, I wanted to mention this to you because this is a scientific journal that is freely available online. Hydrology and Earth System Sciences. Let me write here. And given that it's freely available, it is a useful source of information for you. Hydrology and Earth System Sciences. This is a reputed scientific journal. Of course, this information you do not require to look at any scientific journal for taking your exam. It's just information that I provide to you because I think it is useful and in the case in your future career you need to take some references, I want to put you in the condition to be able to look at the literature, etc. And here is the paper that I wrote for, and it's not really an outstanding paper, it's just an analysis of the river flow, but with advanced visualization techniques. Okay, let me go back now to R. Okay, so now you know that with this blank window, sorry, I close this one and I close also the web. Now you know that with this blank window, you can also plot graphs. So let's start. First of all, let's type 2 plus 2 and press enter, and then magically we get 4. So you can get any computation done with the command line. And also you can write 2 plus 5 times 5 and you get 27. So have a look at the order that R uses for computing operations. Priority to multiplications like Excel, like usual conventions in mathematics. You can use parentheses. So you can write open parentheses 2 plus 5 times 2, which should be 14. Okay? You can use an unlimited number of parentheses, and you can use the 4 basic operations, and also you can use exponential 2, which is e to the power of 2. You can also use the square in this way with the hat. Not the square, sorry, the power. And of course you can also use, if you type now Ctrl plus L, you clean the screen. If you see any difference between what I'm saying and what you experience in Windows, just let me know, because it's useful for me. You can also, of course, write 4 to the power of 0.5, and you get 2. So the square is also possible. The power can be fractional. And the same thing, I've written 4 to the power of 1 divided by 2. Same thing. So the computation is possible. But you may have noticed that I write exp2 for getting the exponential of 2. So let's concentrate on this instruction here, because there is a difference between the 4 basic operations and the power and what I used here. First of all, if you didn't know that the exponential is called exp, you couldn't take it. So this is an example of a function which is predefined in the program, but you have to know it, and also have a look. What you have to know? You have to know the name of the function. So of course exp is the name for exponential, and you need to know it, but the argument of the function is between round parentheses. So this is another thing that you have to know. So every time that you use a function, this is just a first example, you have to put the argument between parentheses. So you have to know what is the name of the function and what are the arguments, because they could be more than one. Okay, let me give to you other examples of functions. And Ctrl L again. Another function, sqrt of 4. Guess what is this? Square root. Another function, log exp2. Let's guess the result. What is, in your opinion, the result? 2. Perfect. Another function, log10, 100. What would be the result? 2. I would say that there are thousands of functions in R. I will now tell you, explain to you some of them. But of course, I can't be exhaustive. My aim, my target is, after giving to you a brief introduction, which I will give to you today, Next time, we will move to an exercise, because I want really to go to the target. We don't have many hours to learn this program, and I still think that the best way to learn how to use a program is to take a problem and to solve it. But of course, what you learn becomes very specific. So you only learn how to develop the exercises that I will propose to you. So for this reason, again, I invite you to download a small guide and try to make your knowledge of the program broader. Okay, and let me think if there are another function which could be interesting is pi. Sorry, it's not pi, it should be PHE, sorry, PHE, no, capital PHE, no, let me see, okay. First of all, this gives to me the opportunity to tell you one thing. It makes a difference between capital letters and lowercase. So always make sure that you use the proper, and then let me try again, because I want to remember what is the name of the function pi. Okay, so usually when I can't find something in R, I go to the web, and I Google R project, and then I Google what I want to find out. So in this case, you see that Google has already a predefined question, R project pi coefficient. Let me see. Its pi coefficient is not the good search. Sorry? You would look for what?
I'm saying pi order maybe is the.
Let's see. Okay. Let's take the problem as an opportunity. So if you can't find on the web what you're looking for, because in this case I can't find it because you know the search term pi is very common. So let's go back to R and let me introduce to you the help. Yeah.
It's just pi without parentheses.
Good. You won a coffee. Okay. But let me now, I want to first of all, before introducing the why I looked for pi, because I wanted to introduce you the trigonometric function. Sin pi, cos pi, which should be 1, yeah, minus 1, and tan, and I think also cotan, let me see. No, it's not cotan, okay, let's forget about it, but there is also a function for the cotangent, I don't know how to say in English, and trigonometric functions are available. Okay, now let me introduce them because it's an opportunity. So you can, if you know the name of a function, but you don't know how to use it, the best thing is to call the help in this way. Question mark, like, question mark followed by exp. And you see a very nice help. You can't see very well here because I magnified the screen, but if I just decrease, you see that the help is very nice. And first of all, here it's giving to me the help from the log because it's the opposite function. So don't be concerned about this. And you see that, for instance, for the log, let me log and exp. For the log, what's interesting, and I didn't know that, is that you can specify the base. So you can put log in the function, and what tells you then? That you have an argument which is x, which is required. There is no default. Okay? It means that you at least need to specify the arguments for which you don't have any default. So x, which is the number of which you want to take the logarithm, of course you don't have any default value. You have to do that. And this is compulsory. The second argument, it's the base. The programs suggest to you a default. And if you don't give any specification for the second argument, it takes the default. So, let me make an experiment. If I take log of 10, it takes the logarithm with base e. But if I say log 10 base equal 10, then it's 1. In the first case, it uses the default. In the second case, it uses the base that I gave to the program. Let me go back to the help. So basically you see in first a description. The format of the help is unique for all the functions. First of all, as I said, you see a description, and then some examples of usage, and then what is much important, the description of the arguments. Description for x, description for base. And then some details. At the end, you have value, which is a description of the output. Then a description of similar functions. And then at the end, you have references, and C also is very useful because it gives to you a description of all the functions that are very close to the logarithm, and then examples, very useful as well. So if you know the name of the function again, the best way to use the help is doing like this. There is a synonym, which is help, open parenthesis, exp, an alias. Let's say that the question mark is an alias for help. Let me go back. But you need to know the name of the function. Maybe that you don't know the name of the function, and then you could guess. Like, if I don't know that the square root, the name of the square root function is sqrt, I could try with help square. And let's see what happens. No documentation. You could try double question mark square. To tell you the truth, every time that I try with a double question mark, what it does is to look in the help for all the terms, in all the, it looks in all the term, all the help entries for the term square. It's not very useful what you get because it's a bit messy. Let me try. You see, it's a bit messy, and here it should give to you, a list of functions where you find the word square. But it's, as I said, maybe it's my problem. I didn't find it helpful because you have a very long list, and then you really can't find what you're looking for. But still, this help is very useful. Okay. Of course, it's in English. Now, let's move forward with another important specification. You can define variable a equal 10. And then you type a and you get 10. This is much useful. of course. But when you define variables, you have to be very careful because you risk to, first of all, you can use whatever name you want. So I can just do like this, and probably in this case it's not taking it because I'm using, characters that are not allowed. But if I avoid the special character, I can define a variable with this name. And as I said, you have to be a bit careful because you easily forget the name of the variables that you define. And therefore, I suggest you to use names that you can easily remember, either because you use a very well-defined name, like river flow equal 100. Or because you use a name that you know what is. For instance, you will see me very often using PR followed by a number. And because I feel comfortable in this way and I can easily remember what is the variable that I define in this way, but this is just my convention. So just try to, when you define variables, to be very, in Italian we say ordinato, means to try to use a logic in the definition of variable that is very clear. And of course it is useful to get a list of the variables that you define, and this list can be taken in this way. RLS, and then you see that I have here the list of the 3 variables that I define. But still, once that you get a very long list, if you didn't define the variable well, then it becomes a problem. The problem in using a named variable like river flow is that long variable names are not handy. They are difficult to use. But the program helps you because you may just type RE and then use the tab, and the program helps you to complete it. You see, I